So yes, this is freezing that you did. So hopefully this is the same that you have written. Okay, when the temperature is decreased, so the kinetic energy of the particle decreases, and as a result, intermolecular distance decreases, the force of attraction increases, or the force of attraction, yes, increases. Therefore, the liquid changes into solid. Am I right?
Yeah.
Good. Okay, as you can see, this was the liquid. The particles were far away from each other. Okay, and you can say you are going to just lower the temperature. You are going to just lower the temperature. So the kinetic energy of these particles would be decreasing. As a result of this, they would be coming close to each other, just like that. So when
Yeah.
they would be coming close to each other, they would be releasing energy. So we can say that the liquid converted into the solid.
Yeah.
Then we have diffusion. Basically, diffusion is the movement of particles from a region of higher concentration to a region of lower concentration. What does it mean? It means that,
Um,
let's suppose you have this container, you are saying something.
no, no, no. Continue.
Okay. Basically, let's suppose we have a container, okay, in which I have two compartments, just like that. So all the gases are over here, okay. You can say it's more concentrated. When the number of particles are higher, so we can say that it is having a higher concentration. Concentration means the number of particles, okay, and you can say that very few particles we have, so we can say that this is less concentrated. This is less
Less
concentrated.
concentrated.
Yes,
Yeah.
exactly, lower concentration. So this is natural phenomena. The particles move from higher to lower. This is the natural phenomena. Like you're not supposed to do anything else. The particles would be converting from, you can say, higher concentration to the lower concentration automatically. Basically, the gradient is required. If you have, let's suppose, jug full of water. Let's suppose this is a jar which is full of water, and I want to pour some more water. I want to pour some more water. This is impossible because we need a gradient. We need a gradient. There should be some space in this jar so that I can add more water. Same goes with this. If we are having a difference of gradient, let's suppose higher concentration and then lower concentration, then the particles would be moving from higher to lower, just like that. Just like that.
Yeah.
As you can see over here, the particles have moved from the higher concentration to the lower concentration, means that from left to right. Left to right. What if we had the same number of particles in both compartments, means they have the same concentration. So you can say that the diffusion would not be happening. Why? Because diffusion needs gradient, diffusion needs difference. Okay, diffusion needs, there is a, you can say, separation in number of particles, I can say, in terms of, like, uh, in the first compartment we have more particles, means more concentration, and in the second compartment we must have a lower concentration, means we must have low number of, small number of particles, you can say the less number of particles. So then the particles would started to move from higher to lower. So then I can say that the particles have diffused from higher concentration to the lower
Lower.
concentration. One of the best example is, let's suppose if you are going to wear a perfume in summers, so obviously I'm standing 15 meters from you, so I would be, you can say, smelling you can say the perfume. Why? Because due to the diffusion, the particles have moved from higher concentration to the lower concentration. Someone is cooking food in the kitchen, let's suppose, and I'm studying in my room, so obviously I would feel. Why? Because due to the diffusion, the particles are moving from high concentration to the lower concentration. When you are cooking food into the kitchen, so obviously over there there would be a more number of particles, higher concentration, higher
Hmm.
concentration. And in my room I'm studying, there is no any particle of, you can say, that. So I can say that here is a lower concentration of particles. So then automatically the diffusion would be started. The particles would be moving from higher concentration to the lower concentration. So this is what the diffusion. But the thing is, the examiner would be asking frequently why the diffusion occurs. What's the
Yeah.
reason? So you will say that, let's suppose I have, you can say this jar, let's suppose, and uh, let's suppose over here I have bromine gas, bromine water, or you can say any gas, and here I have air. You know the color of bromine is brown.
Yeah.
After some time you will see the overall color of the jar would be the same. You can say that the brown color would be diffusing from higher concentration to the lower concentration. But why? You know, the particles of air is also a gas, obviously. The particles of air has a random movement. The particles of air have a random movement. Obviously, they would be moving around randomly. Same goes with the bromine. Same goes with the bromine.
Yeah.
Their particles are also vibrating, you can say moving in a random direction. So ultimately, when they would be colliding with each other, so obviously the particles are intermingled with each other. As a result of this, they would be mixed together. They would be, you can say that they have mixed together. So after few minutes or few seconds, you will see that it would be having, you can say, you can see a homogeneous mixture. Homogeneous means that the color of the whole jar would be the same. This is called homogeneous. The color has mixed evenly into the
Mm-hmm.
jar, in the whole jar. So it's due to the random movement. It's due to the random movement. If there is no any random movement of particles, so you will never see that the diffusion would be taking place. So this is mandatory to have a random movement of the particles, remember. So and also diffusion occurs in gases and in liquids. Diffusion will not happen in solid state, because in the solid the particles do not have a random movement. The particles do not have a random movement, remember. Okay, so then what are the factors on which the diffusion depends? What are the factors on which the diffusion depends? You have two factors. Number one, you have temperature, and then you have molecular mass. You have temperature, and then you have molecular mass. So you can say that higher the temperature, it means that you have provided heat energy to the particles of gases. Ultimately, their kinetic energy would be increasing. As a result of this, they would be moving around randomly in a faster manner. Ultimately, you will see the gases would be diffusing faster as compared to the one when you were having the lower temperature. So they are directly proportional to the temperature. They are directly proportional to the temperature. One of the best example is then when we wear perfume in summers, so the perfume gets diffused faster. And when we wear perfume in winters, obviously the temperature is lower, the kinetic energy is lower, the kinetic energy of the air particles is lower. They are not moving randomly, like they are not moving faster. Okay, they are
Mm-hmm.
not moving faster. So ultimately, the perfume would not spread, would not diffuse in a faster manner due to the temperature. So I can say that the relation between the temperature and the diffusion is directly proportional to each other. Okay.
See.
Okay, as you can see, uh, right now we have a lower temperature. So basically I want to explain how we when we increase the temperature, so how the particles are moving faster, how the particles would be moving faster after increasing the temperature, and how the
Yeah.
particles would be moving slower if you would be if we are going to decrease the temperature. As you can see, when I would be increasing the temperature, so the kinetic energy of the particles would be increasing. As a result of this, they would be moving randomly. you can say they would be diffusing. Would be diffusing from higher concentration to the lower concentration. As you can see, when the particles are at the same place, like you can see a lot of particles, so this is the higher concentration, and the area that is empty, you can say that this is a lower concentration. The thing is that we have to observe, would the particle move from higher concentration to the lower concentration? If yes, so when they would be starting to move, ultimately we have to change the temperature. So let's suppose I have increased the temperature just like that. So as you can see, they are going to have a random movement in a faster manner, a strong vibration. As a result of this, they would be, when they would be, you can say, vibrating. So ultimately, their force of attraction would be weakening. Ultimately, you are going to overcome the force of attraction between the particles of this. So ultimately, the distance between the particles would be increasing just like that. The distance between the particles would be increasing. So ultimately, I can say that the particles have diffused. The particles have diffused from the higher concentration to the lower concentration. So that's what I was saying, that diffusion depends on the temperature. What if I would be decreasing the temperature? Now you can see that I'm going to decrease the temperature. So the kinetic energy of the particles would be decreasing just like that. As a result of this, they would be coming close to each other. Okay. So you can say that the diffusion is going to decrease. The diffusion is going to decrease. So it's all depending on the temperature. Are you getting my point?
Yes.
So these are gases. They are moving randomly. They are moving
You're
randomly.
manipulating it only by changing the temperature, right?
Exactly, exactly. So this was the first factor on which the diffusion depends. We have other factor as well. That is the molecular mass. That is the molecular mass. What does it mean?
Okay.
Molecular mass means, in simple words, I can say that this is the weight. In simple words, I can say that this is the weight. Let's suppose this is a guy which is having 80 kg weight. Let's suppose it's 80 kg, and this is the person which is having, you can say, 20 kg weight. So
Mm-hmm.
ultimately, I can say that the molecular mass is 20 kilogram. Molecular mass is represented by MR, relative molecular mass, and it is 80 kg. So
Uh,
MR is equal to 80. So this guy is heavier. This guy is heavier, and this is lighter. Ultimately, if they would be moving, they would be moving. So who will win the race? Who will win the race? You will say the guy which is having 20 kg weight. Why? Because this is the lighter. It can move faster. It can move faster because they are having the lighter weight. So it's all
uh,
depend on the molecular mass. It's all depend on the weight of the,
molecular
you can
mass
say,
and the weight
substance.
of the
Exactly,
particles.
exactly.
Yeah.
So we have two factors. First factor is the temperature, and another factor is the molecule
The
is having the higher molecular mass. If the
mhm,
molecule is having the higher molecular mass, so
mhm.
can you tell me what the diffusion is, higher or lower?
Diffusion is the movement of particles from a high concentration to a lower concentration.
It would be higher or
It
lower
would
for
be high.
those who are having high weight, like the heavier person,
Yeah.
like the high number. You can say, let's suppose carbon dioxide. The weight of
Mm-hmm.
the carbon dioxide is 44 grams, and the weight of the hydrogen gas is only 2 grams. Carbon dioxide is 44 grams, and
Yeah.
hydrogen gas is only 2 grams. So can you tell me which will diffuse faster, this or this?
The 2 grams
Exactly. Why?
because it has less mass.
Exactly. So it can move faster. Its kinetic energy is higher as compared to the
Yeah, it'll be
molecules
able
of the
to
carbon
diffuse
dioxide.
faster.
Exactly. Exactly. The thing is, how you would be calculating the molecular mass? Sometime the examiner would be giving you the molecular masses. Okay. Sometime the examiner the molecular masses, and sometimes you would be calculating the molecular mass. You would be calculating the molecular mass. For the time being, right now, I'm saying that the carbon dioxide is 44, okay, and the
Yeah.
ammonia is 17. So ultimately, I can say that ammonia would be having a faster rate and carbon dioxide would be having a slower rate. It's due to the
Yeah.
difference in molecular mass, exactly. So you will see a lot of questions just like that. Like the examiner would be giving you a tube and he would be saying, in the first corner of the tube, I have HCl, and on the other side, I have ammonia. So obviously, both are gases. So the both when they both are gases, so they would be diffusing. Ultimately, they would be moving just like that, and they would be moving just like that. Ultimately, they would be meeting at a point. So the
Yeah.
question is, would they meet at point A or point B or point C? So it depends on the molecular masses. As you know that this is 36.5 and this is 17. Ultimately,
So
this is lighter. It would be
yeah, so
moving
we'll meet at
faster.
C.
Exactly. It would be moving faster. It would be moving slower. It would be moving slower. Okay. So when it would be moving slower, ultimately, they would be meeting at point C. So what's the reason you would be giving? You will say that as the molecular mass of NH3 is lower, that is 17, so it would travel faster. And vice versa for HCl, like the mass of HCl is higher, that is 36.5, so it won't be moving faster. Are you getting my point?
Yeah, okay.
Okay. See this question. Explain why hot water evaporates more quickly than the cold water. What would you write then?
Okay, let me compose.
Yes.
Oh, um, so hot water, it
Mm-hmm.
has the molecules within hot water. They
Mm-hmm.
have more energy compared to the molecules in colder water. So it is the increase in energy in hot water
Okay.
makes it easier for the molecules to evaporate, while as the cold water, it makes it more difficult.
Yes, you can say that the cold water, like the kinetic energy of the cold water is lower and the kinetic energy for the hot water is higher. So due to the kinetic energy, obviously their temperature is higher, okay, for the hot water. And the temperature is directly proportional to the average kinetic energy. So they would be moving faster. They would be having a stronger random movement as compared to the one as compared to the cold water. It's having a lower temperature. So the lower movement. So they would not be you can say moving very quickly. Are you getting my
Yeah.
point?
Yeah.
Okay, good, good. Okay. Uh, so I have recorded this. So inshallah, we would be continuing from the same, and we would be doing some past paper. Have you? Do you have some papers related to this IGCSE, or
Yeah, I
should I
did.
send it to you?
Yeah.
Do you have,
Can you
or
send
should I
topic
send it to you?
wise?
Yes, topic wise. Yes.
Oh, okay then. Can
Do
you
you have
send me
states of
for
matter?
topic? Ah, yeah.
Okay, I'm
Can
going
you
to
send
send
me
you
topic
states of
wise?
matter topical paper. Okay.
Should I complete it and then give it to you
Yes,
as homework?
it includes IGCSE, it includes GCSE as a practice and also at Excel. Okay, so
Yeah,
it would
okay.
enhance your concept. Okay, so you are supposed to do first before the next class.
All right.
Okay, thank you. I'm uploading the recording. Okay.
All right.
Okay.